Okay, we're in our example 4 on 3.4. Solve quadratic over a quadratic. Okay, quadratic over a quadratic. You can see that you're solving x squared minus x minus 2 over x squared plus x minus 12. And the inequality is greater than or equal to 0. So our first step is to factor numerator and denominator. Okay, we're going to factor the numerator and the denominator. The numerator, you're looking for two numbers that multiply to -2, add to -1. That becomes x plus 1, x minus 2. In the denominator, we have two numbers that add to +1, multiply to -12. That's going to be x plus 4, x minus 3, greater than or equal to 0. Okay, using our tips and tricks along the way, we're finding out from the numerator that our zeros occur. Maybe yeah, I'll just keep going. Zeros occur from the numerator at x equals -1 and x equals 2. And then we have from the denominator our restrictions occur, which would be the equations of our vertical asymptotes. So we have asymptote at x equals -4 and x equals 3. If you can't remember how to get those really quickly, then you need to go back and review a little bit. Okay, so in order to break this up into its intervals, we want to know what's happening in certain places to see which intervals satisfy the inequality. And so our intervals come from our zeros and our restrictions. Okay, so we're going to draw ourselves a little number line here. Do you already have a number line?
Yep.
Okay, and our leftmost point of interest is x equals -4. So the interval involved here is x less than -4. And then we have what's happening at x equals -4. And I'm going to use a dotted line there just to represent asymptote. And we have an asymptote at +3 as well. So this is x equals 3. I'm probably not going to go that deep because that's a waste of space. So we have this interval, x greater than 3. And then within there, we have our zeros. We have a 0 at -1. And we have a 0 at +2. And so we've split this into, this middle section has 3 different intervals. Okay? We have an interval from -4 to -1. We have an interval from -1 to +2. And we have an interval from +2 to +3. So here we have 5 different intervals to talk about, plus what happens at the zeros, okay? So we don't need to talk about what happens at the asymptotes. We know what happens. The function never crosses there. But we do need to talk about what happens at the zeros because we're involved in a situation where we're looking for a greater than or equal to, okay? So all we're going to do is use the table, and we're going to make a table. Do you guys have a table drawn already?
Yeah.
That's really helpful. Does it have the intervals in it?
No, it has a spot there, the little spot.
Okay, so we're going to use the table, and we're going to consider all of these factors, 1, 2, 3, 4, and we're just going to figure out if this whole thing is positive, negative, or 0 in each of these 5 intervals. Okay, so you've got your intervals. Our first interval is going to be from -∞ to -4. Okay, Our next interval is going to be from -4 to -1. -1 is a 0, so we want to know what's happening there. Then we're going to go from -1 to +2. We're going to figure out what's at +2 because that's a 0. Then we're going to go from 2 to 3. And then we're going to look at what happens to the right of 3. And in your next column, we have test points. So your test point for these intervals is any number within that interval. So from -4 to -infinity, the easiest number to work with is probably -5. You can just go through and pick the easiest test point, and it's going to be x equals each time. X equals -2 in that interval. This is really easy. If x equals -1, it has to be -1. Here we could choose x equals 0. X equals 2, we don't get to choose. X equals 2.5 is right in between 2 and 3. And x equals 4 is the easiest one in that last interval. In the next column, we are taking our rational equation, our rational expression right here on the left-hand side, and we're basically going to simplify it into positives and negatives. So we're looking at the signs of if I guess I can write it in, looking at the signs of each of the factors, x plus 1, x minus 2 in the top, x plus 4, x minus 3 in the bottom. Okay, so basically when we put in our test value, what happens to each of these factors? And then in our last column, we're basically just going to count the negative factors and see if the overall expression, sign of x plus 1, x minus 2 over x plus 4, x minus 3. Okay, so again, regrouping. What's the point? We want to know what the function is doing in each of these intervals. So we've listed each of our intervals. We chose a point within them. This is going to tell us whether at that test point, this interval is either positive or negative. It's either above the x-axis or below the x-axis. Okay? Same with this interval, same with this interval, this interval, this interval. So first we're going to write down the sign of each factor. Then from that, we're going to determine the sign of the overall function, if it's positive or negative. Okay, here we go. So we put in -5 into each of these factors. We end up x plus 1 ends up being negative. So the only thing we need to write is a negative sign. Okay, we're not getting an exact value. We're just finding out if it's positive or negative in that interval. X minus 2, that's going to be negative. X plus 4, that's going to be negative. And x minus 3, that's going to be negative. Okay, so we find out that we have 4 negative factors. Negative times a negative is a positive. Divided by a positive is a positive. So the function in this interval over here is actually going to be positive. Okay. Next interval, we're using the test point of -2. The first bracket would be negative. The second one would be negative. And then we're over x plus 4, that's going to be positive, and x minus 3, that's going to be negative. We have 3 negative factors, which means it's negative at that point. Okay, x equals -1. Look at what happens. In the numerator, you get one factor of 0. 0 times anything is 0. 0 divided by anything is 0. So this one ends up being 0. Okay, if you wanted to write out the factors, I'll do it this time just so that we can see it. This first factor becomes 0. The next factor is negative. In the denominator, you have positive times negative, but none of that matters because there's a 0 in the numerator, so it's 0. Okay. In our next section, our test point is x equals 0. So we're going to go through. I'm just going to erase that one to give myself more space. it's 0, so it's whatever's in there is going to be the sign. So the first one's positive, second one's negative, over, positive, negative, two negative factors, a negative over a negative, that's positive. So you can see you have a change of sign at x equals -1. Then we have a test value of 2. That one's going to end up being 0 for the same reason that -1 was 0. Then for in between 2 and 3, we chose the test point 2.5. So we've got positive, 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 negative. One negative factor makes the whole thing negative. And then a test point of 4. They're all going to be positive. Every factor is going to be positive, so it's positive. If you do this right, you can kind of see the pattern that happens if you're working from left to right on your number line. You end up with all of them, in this case, all of them being one sign, then one of them switched, then a second one switched, then a third one switched, then they're all positive. Okay, so if you've done it right, that is generally what will happen as you work across the intervals. Okay, what did that actually tell us? Basically, it just told us where this function is positive, negative, or 0. So basically, we can see where our inequality is satisfied. So from the table, we can say, therefore, the solution and maybe I'll write it actually under my table. The solution is, we're going to write it in 3 different ways. We're going to write it as inequality, then in interval notation, then as a number line, so that you know how to do all 3. Okay? Interval notation looks like this. So we're basically going to include all the points that are 0 or positive. So there's a positive, there's this whole thing is going to be all 1, and there's a positive. Okay? So the solution as inequality first is everything to the left of -4. So x less than -4. Anything from -1 to 2 inclusive. So -1, and then a x is greater than or equal to, and then is less than or equal to 2. And then anything to the right of 3, but not including 3. So x greater than 3. As interval notation, that means round and square brackets, we would say x belongs to the set of numbers from -infinity to -4. And then we're going to go from -1 to +2, but we're going to include those. So we have the union of, and then square brackets, because it's inclusive, -1 to +2, or from 3 to +infinity, excluding 3. And the last way we can show it is on a number line. On the number line, I would mark our key points. So we have 4, sorry, -4. You've got -1. You've got 2. And you've got 3. Yours can be prettier if you want. But basically we can read this, so we've got anything to the left of -4 not including -4, so that's an open dot, and then everything to the left of -4. Then we have from -1 to +2 inclusive, so that's going to be a solid dot at both of those points, and a solid line in between. And then we have to the right of 3 not including 3, so that's an open dot. If you're not sure what these things are called, this is solution as inequalities, interval notation, and number line. Again, running through the steps really quick. You have a complicated quadratic over a quadratic. As part of the inequality, factor top and bottom to get your key points along your x value. So you get your zeros and you get your asymptotes. From there, you build your table of values. You find out a test point within each interval. Test each factor within each interval using that test point. Determine the sign of the whole expression. And then you can just circle your solutions, determine which intervals actually serve as solutions. Represented as this they don't normally call this like express your answer as an inequality. This would just be the solution. This is the solution in interval notation. This is number line. Carry on, carry on. That is the end of 3.4. Do you guys have a graph there or no?